Hey, welcome. Have you ever really looked at the texture on your favorite polo shirt and wondered how they do that? Well, today, we're going to unravel the story of a technology that started with just simple patterns and, believe it or not, is now weaving its way right into the heart of smart, sustainable manufacturing.
It really does sound like a riddle, doesn't it? I mean, what on earth could a casual piece of clothing have in common with a super advanced industrial robot? Well, the answer, as you're about to see, is this brilliant piece of engineering that's been evolving for more than a century. The Dobby loom.
Now, you might not know the name Dobby, but I can pretty much guarantee you've seen it, and you've probably worn it. It's that unique kind of raised texture you feel on peak polo shirts. It's what gives a dress shirt that subtle, really sophisticated pattern. It's a go-to for everything from skirts to checkered shirts, because that woven-in texture just makes the design pop.
So what is it exactly? Okay, a Dobby weave is all about creating these small geometric patterns, but, and this is the key takeaway here, these patterns aren't printed or dyed on top of the fabric. Nope, they are physically woven into the fabric by a special mechanism right on the loom. Its texture and design all born at the exact same moment.
All right, so here's our roadmap. We'll kick things off with the familiar fabric hanging in your closet. Then we'll dive deep into the mechanics that make it. We're going to explore how it evolved for speed, see how modern looms are literally getting a brain, and then we'll wrap up by tackling the super important question of its carbon footprint. Okay, so before we can really get into the Dobby itself, we've got to cover some of the basics. It all begins with the ancient process of weaving. You know, the fundamental way we turn simple thread into the textiles we use every day.
You know, at its core, weaving is actually pretty simple. It's just interlacing two sets of threads. The threads running up and down, the vertical ones, are called the warp, and the threads that go side to side, horizontally, are called the weft. The machine that orchestrates this whole dance is the loom, and the real magic is in how it lifts and lowers those warp threads to make a pattern.
So looms come in a few main flavors, and you can kind of think of them in a good, better, best way when it comes to pattern complexity. The tappet loom, that's your workhorse for really simple weaves. On the other end, the jacquard is the absolute master. We're talking control over 1,200 individual yarns for massive, incredibly detailed designs. And right there, in that perfect sweet spot in the middle, that's the Dobby. It's way more versatile than the tappet, and it's the key to creating all those cool, small, geometric patterns we love.
All right, so how in the world does the Dobby mechanism actually pull this off? Let's pop the hood and take a look at the ingenious mechanical heart of this amazing machine.
Okay, first thing you need to get your head around is something called the heeled frame. Just picture a rectangular frame holding hundreds of little wires, and those are called heddles. Every single warp thread has to pass through a tiny eye in one of those heddles. So when the loom lifts a heeled frame, it's lifting a very specific group of threads. And the Dobby's job? It's the conductor, telling each frame exactly when to lift up and when to stay down.
Okay, look at this. What you're seeing is this incredible mechanical dance. It all starts with a pattern chain. It kind of looks like a bike chain, but with these little bumps called risers. As that chain moves along, a riser pushes a lever up. That simple little action engages a set of gears, which then turn just enough to move another lever, which then lifts the entire heeled frame. Get this, what you're looking at is basically a mechanical computer. The bumps on the chain are the code. They're the program telling the machine what to weave. This is a direct ancestor to the punch cards that powered the very first digital computers. All of that amazing complexity just to create the pattern in your shirt.
So that mechanical system was just genius, right? But you know how it goes in the world of industrial manufacturing. There's always one constant demand: go faster. And that pressure led to a totally revolutionary new design.
See, the big problem with those older Dobbys, with all their levers and gears starting and stopping, was that they just had a built-in speed limit. The sheer physics of it all, moving all those heavy parts back and forth, created a ceiling on production. To weave more fabric faster and more reliably, the machine couldn't just be strong. It had to get a whole lot smarter and smoother.
And the solution was the rotary Dobby. The game-changing innovation here is replacing all that jerky back-and-forth motion with continuous rotation. You have a main shaft that just rotates non-stop, and a really clever system of controlled latches can engage or disengage the mechanism for each heeled frame on the fly. It totally gets rid of that violent start-stop motion and allows for way, way higher weaving speeds.
So, we've journeyed from mechanical chains to high-speed rotary machines. But the quest for efficiency didn't just stop with better mechanics. The next leap wasn't about moving faster.
It was about moving smarter. This, my friends, is where the loom gets a brain.
We are now stepping into what people are calling Industry 5.0, and it's not about replacing Industry 4.0 with its focus on automation and data. Think of it more like a complement, an upgrade. Industry 5.0 brings a critical element back into the picture: human well-being and sustainability. The goal isn't just efficiency at any cost anymore. It's about being efficient in a way that's safe for workers and that minimizes our impact on the environment.
So what does this actually look like in the real world? Well, picture a smart textile mill. You've got IoT cameras everywhere, constantly monitoring the factory floor. An edge AI system, where the brain is right there on the device so it can react instantly, uses something called visual wake words. It's kind of like your voice assistant that wakes up when you say its name, but this AI wakes up when it sees a human. If a person gets too close to a running loom, the AI can instantly sound a warning or even shut the machine down. And all that data isn't just for safety. It's also used to optimize the entire factory workflow.
This new level of intelligence is amazing, right? It makes factories safer and way more efficient. But it also opens the door for us to tackle one of the biggest challenges in manufacturing today: the environmental cost. I mean, we've built these incredible machines that can weave beautiful, intricate patterns at unbelievable speeds. But all that production, it takes a ton of energy. So what's the real cost hiding behind the price tag?
Now this chart, this tells a really shocking story. The carbon footprint of a factory depends dramatically on where it is. A smart loom running in France, which gets most of its electricity from low CO2 nuclear power, has a tiny footprint. That same loom in Spain, with a solid mix of renewables, is also looking pretty good, but you take that exact same super efficient loom and you put it in a place like Alberta, which relies heavily on natural gas and coal, and its carbon emissions just skyrocket. It's the exact same machine, but where you plug it in changes everything.
And this brings us right to the cutting edge of innovation, something called Green IoT, or GIoT. The whole point here is to make the technology itself part of the solution. Of course, this means powering factories with renewables, but it gets even more creative. I mean, can you imagine looms that actually harvest energy from their own motion or the heat they generate? It's about designing computer chips and software from the ground up to be as energy efficient as humanly possible. It's about weaving a greener thread into the very fabric of our technology.
Wow. So we've gone on this huge journey, all the way from a simple polo shirt to a global network of smart, interconnected machines that are facing a massive environmental challenge. The simple act of weaving has become this complex dance of mechanics, data, and energy. And all of this leaves us with one big question to think about. The next generation of fabric will be woven not just with thread, but with data and a conscience. Are we ready?